Hello everyone. Today we are going to discuss one of the important consequences of Lorentz transformation. We have already learned the consequences length contraction and time dilation. Relativity of simultaneity is one of the major consequences of Lorentz transformation. Relativity of simultaneity states that two events which are simultaneous in one inertial frame of reference are not in general simultaneous in another. Two events which are simultaneous means two events that occur at the same time in one inertial frame of reference is not in general simultaneous in another frame of reference. Let us discuss this in detail. For example, consider one compartment of a train. This compartment moves along a straight track with a uniform speed v. Let the front end of the compartment be marked as A and the back end be marked as B. Now consider a light bulb hanging at the center O of the compartment. Now we consider an observer inside the compartment. When the light bulb is switched on, the light pulse is propagating in all directions with a uniform speed c. So, for an observer inside the compartment, the light pulse reaches the end A and the end B at the same time. That is, it occurs simultaneously. Now, we consider an observer on the ground. For an observer on the ground, let at time t0 this light pulse starts propagating from the point O. After a time t, since the compartment is moving in the forward direction, the back end B will be at this position and the end A will be at this position. So, the light pulse propagating from this point has to travel a shorter distance to reach the point B and it has to travel a longer distance to reach the point A. That is, for an observer on the ground, it will reach the both ends at different times. That is, the event is not simultaneous. That is, the simultaneity is a relative concept but not an absolute one. If it is an absolute one, the two events which occur simultaneous in one inertial frame of reference is also will be simultaneous in another inertial frame of reference. But it is not so. That is why we say simultaneity is not an absolute concept, it is a relative one. So, we consider let the two events occur inside the compartment in an inertial frame S. We consider an inertial frame S and the two events occurred in the inertial frame S simultaneously. Let at time t0. Let we drop two balls at the same time t0. So, the balls will be dropped at position x1 and x2. That is, two balls are dropping at same time t0, but it happens at different positions x1 and x2. Now, consider an observer in the S dash frame. This S dash frame is moving with velocity v. For an observer in the S dash frame, we have t1 dash equals t0 minus vx1 by c square by root of 1 minus v square by c square, and t2 dash equals t0 minus, here the position is different, vx2 by c square by root of 1 minus v square by c square. Then the time interval t1 dash minus t2 dash or t2 dash minus t1 dash equals t2 dash minus t1 dash equals minus v by c square into x2 minus x1. On subtracting this, t2 dash minus t1 dash minus v by c square into x2 minus x1 divided by root of 1 minus v square by c square. That is, t2 dash minus t1 dash not equals 0. If it is equal 0, it means the two events are simultaneous to an observer in S dash frame. Here x1 not equals x2. x1 cannot be equal to x2. So, t2 dash minus t1 dash is not equals 0. That is, the two events are not simultaneous to an observer in S dash frame. The events which are simultaneous in S frame are not in general simultaneous to an observer in the S dash frame. That is, the relativity. Simultaneity is a relative concept, not an absolute one. Thank you.